Now we'll start solving the revision sheet. Okay, the first exercise, what do we have? Exercise number 1. We have 3 sets, E, A, and B. So in the given, we have 3 sets, E, A, and B. E is the set which includes the digits, X, such that X is a digit. What are the digits? We know that the digits are 0, 1, 2, 3, so on until 9. These are the digits. Is 10 a digit? No. أكيد لا. From 0 to 9, these are the digits. Okay. Now, what about set A? X, such that X is a divisor of 10. X is a divisor of 10. This is A. What are the divisors of 10? This means what are the numbers that gives 10 when multiplied by each other? They are 1 and 10, 2 and 5. في غيرهم شيء؟ فإذن 1, 10, 2, 5. So we put them in the set 1, 2, 5, 10. These are the divisors of 10. Now we are asked to write B in comprehension. We have B. This is 1, 2, 3, 4, 6. عادة نحن قلنا لما تكون بتبلش ب 1 maybe تكون X belongs to E. نقول لازم تكون divisor of حدا. X is a divisor of what? Whole أرقام 1, 2, 3, 4, 6 are divisors of what? Of 6, for example. بيزبطوا كلهم من عدا ال 4 لأن 6 cannot be divided by 4. In fact, they are divisors of 12. طيب يعني شو يعني هات لنفكر سوا شو يعني divisor of 12 يعني 1 times 12 أو 2 times 6 أو 3 times 4. Look شو هن divisors of 12. 1 مظبوطة 2 مظبوطة 3 4 6. طب 12 وينها؟ We can't take 12 لأنه نحن قلنا X belongs to E. So كتبنا B هون X belongs to E such that X is a divisor of 12. Now we go to the part 2. إذا ما فهمنا هون بنرجع بنعيدها بعد مرة. شو يعني 1 2 3 4 6 these are بدي انتبه أنا إنه هن عبارة كانوا عن divisors لحدا. بجرب اضربه ببعض مثلا 1 times 6 6 2 times 4 8 ما زبط لا لازم يعطوني نفس الجواب. طب 2 times 6 12 3 times 4 12 عال 1 times 12 12 بس 12 ما في اصلا ما فينا ناخذ 12 لانه باليونيفرسال سيت اي ما في 12 so هن هول divisors of 12 بس من عدا ال 12 حتى in order to exclude 12 شو بنقول x belongs to e. لما قلنا belongs to e يعني بدي نقي divisors لل 12 اللي موجودين بالاي بس. مين هن؟ تعالوا ننقي هون in e the divisors of 12. They are 1 2 3 4 6. فإذا x يلي هو set b x is a divisor of 12. Now we go to the second part. This was the first part. The second part بيقول write an extension A intersection B. What do you mean by A intersection B, or we read it A and B? It means the common elements between A and B. تعالوا ندور على common elements حبيباتي. A 1 is common, 2 is common also. Then the common elements 1 and 2. This is A intersection B. What about A union B? This we read A or B. This means we list the elements that are found in A or in B. يعني كل الاليمنتس الموجودين بالA او بالB. يعني في 1 موجود، في 2 موجود، 3 موجود بالB، 4 موجودة بالB، 5 in A، 6 in B، 7 و8 و9 مش موجودين. 10 ليش ما حدا لفت لنا نظرنا انه في عندنا غلط؟ Here we have a mistake. لانه نحن قلنا x is a divisor of 10. صح 10 is a divisor بس 10 is not found in E. So A هون لازم تكون بس 1 2 5. إذا هون خلص A union B. ما في 10 in A. Finally we want to find أو قبل في عنا A bar intersection B Olivet bar. A bar intersection B bar. Okay. We have several ways أو we have more than a way to do this. بس نحن فينا نختار هالدي مورغانز رول اللي بيقول إنه هيدا البار الكبير we can split it ليصير عنا A bar B bar وبالنص الانترسكشن شو بتصير؟ union. صح؟ فإذا شو عملنا؟ we split the complement this one. قسمناه قسمين، مرة فوق ال A bar ومرة فوق ال B. we get A double bar. A double bar حبيباتي it means what? A. لأنه not A بنرجع لل A. إذا صار عندنا هون A union B bar. طب وين ال A وين ال B bar؟ خلينا نعملهم union. We have here A is 1 2 5. This is A 1 2 5. What about B? This is B. I want B bar. شو يعني B bar? These are the elements that are found in B in E, sorry, and not in B. يعني هن ال elements that are in E but not in B. I want not B. This means I don't want 1 2 3 4 6. شو بضل في عندي؟ 0 5 7 8 9. 0 5 7 8 9. إذن رح نقول ال A هي 1 2 5 وال B bar is 0 5 7 8 9. هاي ال B bar. أنا شو كان مطلوب مني؟ كان مطلوب مني طلع A bar intersection B كلها بار، وزعت البار عليهم A بار و B بار وقلبنا الانترسكشن لليونيون ساعتها. Now we get A double bar it means A union وهي خليناها مثل ما هي B bar. Now A union B bar شو بيعطيني؟ I want the union of these two sets. This means list all the elements that found in these two sets. يعني 0 1 2 5 7 8 9. Okay. Now we go back to the parts of A finally in this question. Parts of A. What are the parts of A? We know that A is 1 2 5. What are the subsets? All the subsets of A. Yalla, let's list them together. First of all, we have the empty set. Then I have singleton 1, singleton 2, singleton 5. Then we have the pair 1 2, the pair 1 5, the pair 2 5. Then finally I have the set 1 2 5 which is A. These are all the subsets of A which we call it the parts of A. لازم قد يكون عدد الاليمنتس. إذا كانت الست الأساسية فيها الكارد تبعها 3 card of A is 3, then the number of elements اللي بنسميه card of the parts of A لازم يكون قديش؟ 2 power 3 which is 8. 1 2 3 4 5 6 7 8. مظبوط؟ Now let's go to the second exercise, number 2. What do we have? we have to write in extension also two sets. The first set is E. This is X belongs to the set of real numbers R such that absolute X minus 2 into X squared minus 3 is equal to 0. We want to find the real numbers X. We want to find X يعني بكل بساطة. And we want to solve this one. According to the product rule from grade 7, إذا أنا عندي product equal to 0, then each of one at least must be equal to 0. This means X minus 2 equals to 0 or X squared minus 3 equals to 0. As we know, in the absolute value, if X minus 2 is equal to 0, this means X minus 2 is 0, then X is equal to 2. Now X squared here is equal to 3 square root. أخذناهم بدرس الباور. With 3 هي positive, we get 2 square roots plus or minus radical 3. So by conclusion, E in extension هي عبارة عن 3 أرقام من minus radical 3 بالترتيب radical 3 و 2. This is set E in extension. طيب, what about the second set? It was F. F بتقول X belong to E such that X is irrational. F, X belongs to E. So I have to choose one of the elements of E, one or more, such that X is irrational. Irrational. What are the irrational numbers? It cannot be written as a fraction. It's found in E. 2. 2 is rational. 2 is مش بس rational. 2 is a natural number كمان. So the irrational numbers in E are minus radical 3 and radical 3. This is in extension. Okay. Now, exercise number 3. We have 3 intervals A, B, and C. We need to find the intersection, the union, and sometimes the complement of each interval. First, let's find the intersection and union between the two intervals A and B. To do this, we need to represent the intervals on a number line. The axis minus infinity plus infinity. We have A is set from minus infinity, from minus 6 to minus 1. From minus 6 to minus 1. This is minus 6, for example, and this is minus 1, let's say. So it's a set of numbers included between minus 6 and minus 1. We can color it, for example, like this. The other set, which is B, is from minus 1. We'll use dots on minus 1 because it's an open interval, like this. From minus 1 to plus infinity. Okay. Let's color this region. Now, where's the intersection between the two regions? In fact, as you see, there is no intersection. A intersection B is equal to empty set. No common between the two areas. The only possible common minus 1 is not included in B, so it cannot be considered as a common element. What about the union? A or B, the set of all numbers in A or in B, which makes from minus 6 to plus infinity. Now, what about A intersection B, C, and A union C? Again, A is the set of numbers between minus 6 and minus 1. C is the set of numbers between minus infinity and 2. This is 2. And this is minus infinity. So, where's the common area? as you see, the common area is here between -6 and -1. So C here is the subset of A. The common between A and C is C itself, and the union is A. For this reason, we say the common between A and C is A. Sorry, is A itself, and the union is C. It's from -infinity to 2. What about the third one? -infinity plus infinity. Now B and C. I want the common between B and C. Where's B? B is the set of numbers from -1 towards +infinity. These numbers. However, C is the set of numbers from 2. Let's say 2 is here. From 2 to -infinity. So now where's the common region between the two intervals? This is the common region. So we say that the solution is A intersection B is the set from -1 to 2. 2 is closed and -1 from B is open. يعني لازم نعملها dotted. طيب. What about A union B? A union B, as you see, when المنطقة اللي عليها shading, you can see the shaded area everywhere. So the union between the two sets is -infinity plus infinity. Fine. Now, finally, we want to find A bar, B bar, and C bar. To do this, in fact, what do we mean by A bar? Not in A. If this is A, from -6 to -1, A bar is outside this area. We get two intervals here and here. So we say A bar is from -infinity to -6. Since -6 is closed here, it becomes open. Union, the second interval is from -1 to +infinity. This is A bar. In the same way, we can do B bar and C bar. B is -1, for example. B is -1 plus infinity. C is -infinity 2. So in the number line, this is B. This is B. So this is B bar. It's from -infinity until -1. -1 here is open, here it becomes closed. However, -infinity always is open. The boundary of the -infinity is always open. Now, what about C? From -infinity to +infinity, this is 2. Okay. 2 to -infinity represents the set C. So here we get C bar is from 2 to +infinity. And 2 here is closed to here, it becomes open. What about exercise number 4? Here we have to solve some equations containing absolute value. The first one, 3x minus 5 in absolute is equal to x minus 1 in absolute. Absolute A equals to absolute B. What do we do in this case? We say A equals to B, or A is equal to minus B, as mentioned before. Have two cases. Now here, what do we say? 3x minus 5 equals to x minus 1, or 3x minus 5 equals minus x plus 1. Change the sign. We solve for x. Here we get 2x equals to 4, and consequently x equals to 2. Here, bring x to here, we get 4x equals 1 plus 5, 6. X is 6 over 4, or 1.5, for example, or 3 over 2, if you want. If you want it as a fraction, 3 over 2. This was the first one. What about the second equation? We have x squared plus 1 in absolute minus 2 in another absolute, and here we have a problem. Two absolute in each other. In fact, حبيباتي, here we have a trick. X squared plus 1 inside an absolute value. X squared plus 1 is always a positive quantity. So the absolute of x squared plus 1 is the same as x squared plus 1. Why? There's no need for the absolute. لأنه أصلا x squared plus 1 is a positive quantity whatever the value of x is. شو ما كان value of x, x squared plus 1 is positive. So there's no need to do absolute for it. It's positive أصلا. So the absolute of x squared plus 1 can be removed. We can write instead x squared plus 1. So we remove this absolute. Minus 2 بس بعد في الابسوليوت اللي برا equal to 3. Now x squared plus 1 minus 2, 1 minus 2, we get x squared minus 1. Absolute equal to 3. Now this absolute cannot be removed مثل ما عملنا هون. X squared plus 1 is always positive, but x squared minus 1 is not always positive. Here we have a difference between two numbers, يعني يمكن يطلع negative. بس the sum of two positive numbers مستحيل يطلع negative. So هون هلا ما فينا نشيل الابسولوت, بس in order to remove the absolute we have to take two cases مثل ما عملنا هون. This means x squared minus 1 equal to 3 or x squared minus 1 equals to minus 3. In the second case, we take minus 1 لهونيك, we get x squared equal to minus 2, and this is impossible. No real solution, because as we have learned in the first lesson, x squared equal to negative is not possible. However, here we get x squared equal to 4 and square equal to a positive number. This means x is equal to the plus or minus of the square root of 4, which is radical 4 is 2. So here's the final answer. What about the third exercise or the third equation, sorry. Here we have an inequality, in fact. X minus 3 less than 7. خلينا نتذكر سوا شو كانت الرول تبع inequality. If we have absolute A less than B will be positive, we say A less than B or A less than minus B, أو بطريقة تانية تعلمناها إنه نعملها double inequality وأنتوا حرين تختاروا الأسهل. يعني we put A in the middle, minus B from the left and B from the right. So back to our exercise, we put X minus 3 in the middle على شرط تكون هون positive. X minus 3 in the middle, 7 from the right and minus 7 from the left. Then what do we do here? Add 3 to all sides. What do we get? Minus 7 plus 3. X minus 3 plus 3, we get X. With 7 plus 3, we get 10. This is the final answer. X is between minus 4 and 10. What about the second one? Or the next one? 1 minus X is less than 5. The same way, we put 1 minus X in the middle. 5 and minus 5 from the both sides. Now we want to get rid of 1 here. 1 is positive. We get rid from 1 by subtracting, not adding. We subtract 1, opposite to it. So we put minus 1 on all sides. What do we get? Minus 5 minus 1, it's minus 6. 1 minus 1 is 0. بيضل عنا minus x. And 5 minus 1, we get 4. But now, ما خلص السؤال. Why? Still we need x and not minus x. For this reason, multiply the whole equation by minus or minus 1, for example. Here, what do we get in this case, حبيباتي? انتبهوا. Minus x times minus 1 is x. 4 times minus 1 is minus 4. Minus 6 times minus 1 is 6. اهو صار 6 من تحت وماينس 4 من فوق، في شيء مش طبيعي. شو هو اللي مش طبيعي؟ We know from grade 8 when we multiply an inequality by minus, we have to reverse the sign of the inequality. The less than becomes greater than. So here we get the answer. X is included between minus 4 from below and 6 from above. Okay, this was the final answer. What about the coming one? We have absolute value of minus 2x plus 5 greater than or equal to 11. طب شو بنعمل بهالحالة؟ Absolute A أكبر من B will be positive. We say A greater than B or A less than or equal to minus B. Let's apply this rule here. We take this one, we say it's greater than 11 or it's less than the opposite of 11. And we solve for X. Minus 2X, 6 here, 11 minus 5, then X is 6 divided by minus 2, we get minus 3. But since we are dividing both sides, look, if we are dividing both sides by minus 2, dividing by negative, we have to switch the inequality. And here we get X, here we get minus 3. This is the first one. The second one here, minus 2x is less than minus 11, minus 5, minus 16. Again, we do the same here. We divide both sides by minus 2. بس هذا الشيء حقه انه نقلب inequality. يطلع عندي x is greater than minus 6 divided by minus 2, 8. By the way, we can write this as an interval. نحن عندنا or يعني union. عندنا x less than minus 3 يعني من minus infinity ل minus 3 or x greater than 8 يعني from 8 to plus infinity. This is the solution. What else? Absolute 2x minus 1 plus 4 greater than or equal to 7. يلا سوا. Absolute 2x minus 1, 7 minus 4 is 3. Now we apply the same rule. 2x minus 1 greater than 3 or 2x minus 1 less than or equal to the negative of 3. Here we get 2x أكبر من 4 يعني x greater than 2. 2x here minus 3 plus 1 minus 2. We divide by 2, we get minus 1. Also, we can write this as an interval. X greater than 2 is 2 to plus infinity. Close لأنه في equal. What about this one? X less than minus 1 لأنه هو أصغر حأكتبه بالأول. X less than minus 1 يعني from minus infinity to minus 1. ويونيون. This is the solution. هي إذا حبينا، إذا كان بالسؤال عم بقول لك write in the form of an interval. Finally بضل في عندنا اثنين شو هن؟ X minus 6 less than 0 وبعد في وحدة 3 minus absolute X plus 1 less than or equal to 6. بالنسبة لأول وحدة less than 0 absolute value less than 0, this is no, we have here no real solution. It cannot work. ما في absolute value يطلع أقل من 0. Now what about the second one? Let's isolate the absolute value. Take 3 to the right hand side. We get minus absolute x plus 1 less than or equal to 6 minus 3, which is 3. Multiply the whole inequality or divide it by minus 1. حيلا ما بيأثر to get rid of the minus here. We get x plus 1. نقلب inequality لأنه عم نضرب بماينس وتصير هون minus 3. إذا دايما to get rid of the minus we multiply by minus 1 أو divide by minus 1. In both cases we have to switch or reverse the inequality, the sign of the inequality. صار عندي x plus 1 راحت الماينس وثاني ميلي 3 صارت minus 3 والinequality صارت بدل less than صارت greater than. طب now this side is negative and this side is an absolute which is positive. We have to judge either no solution or infinite solutions. Now we are asking when is the absolute greater than the negative number? This happens always لأنه دايما الابسوليوت هو positive أكيد هو أكبر من negative number. So the answer is we have infinite solutions. Moving to the exercise number 5. Exercise number 5 دخلت لكم فيه شوية absolute value بس كمان based on ideas from grade 8 يعني something that you have to know. نحن بنعرف بالصف الثامن انه كان يسألنا for what values of x the expression is defined, the rational expression is defined. لازم ال denominator يكون the idea انه the denominator must be different from 0. So here what is the denominator? It's absolute x minus 2. We put it different from 0. Now we deal it as we are dealing with the equation equal. Take 2 to the right hand side. Now to remove the absolute value we have to pay 2 to what? 2 cases which are either plus or minus. Here we say that A is defined for all real numbers, for all values of x, or for all real numbers, except minus 2 and 2. Let's try another one. In the second one, we have B equals 3 divided by absolute x plus 2 minus 1. How to find the set of values of x where b is defined? We put the denominator different from 0. This denominator is x plus 2 minus 1 different from 0. Isolate the absolute value and take 1 to the right hand side. Then here we say x plus 2 different from 1. We have to take 2 cases, صح? Or x plus 2 different from minus 1. Here, x different 1 minus 2, x differs from minus 1 minus 2 minus 3. We say b is defined for all real numbers except minus 1 and minus 3, or minus 3 and minus 1. Okay. Finally, the third one, the third example, c is equal to what? 1 over 3 plus absolute x. Also in the same manner, we say that the denominator must be different. The denominator must be different from 0. This is condition. 3 plus absolute x must be different from 0. Absolute x different from, take 3 to the right hand side, we get minus 3. Now we get a comparison between absolute and a negative number. هون we have to judge about it. ما فينا نحلها، ما فينا ناخذ مره بلس ومره ماينس، لانه اصلا الابسوليوت مستحيل يكون equal to negative number. It's impossible to be equal. But is it different from minus 3? This is true always. انتبهوا، شفتوا الفرق شو عم نقول؟ على طول هي different. يعني حارجع اعيد شو عم بقول انا. اذا قلت لك absolute x equal a negative 5, this is impossible. We say no real solution. It is impossible to be equal. أما إذا قلت لك absolute x, when does the absolute x equals to أو different from negative 5? أنت بيكون absolute different from minus 5. This is true. This is evident. This is trivial. This occurs and happens always. So in this case, we say we have infinite solutions. In other words, يعني هون ما في عنا value for x to be restricted، او ما في condition انه ما في x معينه ممنوعه. باول example بالاي كان ممنوع نختار رقمين هن -2 و2، فاذا فينا نختار all real numbers except -2 and 2. In the second one كان عندنا all real numbers except -1 and -3. In this one we say C is defined for all real numbers without exception. ما في except حدا، لأنه ما طلع عنا x different from حدا. عنا x absolute x different from -3. This is true always. ما في داعي نعمل exception لحدا. So C is defined for all real numbers.